Hi, my name is Koki Tamura. I will now begin my presentation. First, I will build a small synchronous generator experimental system that can learn the generator characteristic from the turbine characteristic and combine it with a load or other modules to simulate the system and conduct experiments. The social background to this research is that the introduction of renewable energy is increasing due to the recent rise in environmental awareness and the expected depletion of fossil fuels. As a result, the grid is expected to become more complex and the demand for power engineers is expected to increase. Therefore, it is necessary to train and strengthen power engineers. Next, in terms of technological background, conventional educational training equipment is large and expensive and only a limited number of experiments can be conducted. Therefore, we have decided to develop a small modular experimental device that can be used for a wide range of experiments. The modular experimental system is defined by this standard and is mainly a cubic structure of 300 millimeter square and is operated by a three-phase three-wire system or a single-phase three-wire system. The main features are that it is relatively inexpensive to build, easy to connect, and reconfigure the circuit. Easy to understand the overall flow of the system and possible to conduct experiments on a desk. The, the following is a report on the characteristics of each module and its operation experiments. The next step is to experiment with the operation of the fabricated module. In the experiment, the target values of rotation speed and output voltage are set to 1500 RPM and 200 volt, respectively, and the load of 75 watt is applied and released every 5 seconds from the state where the waveform is constant. Check if the output control can be performed according to the output fluctuation caused by the load change. This graph shows the waveforms obtained from the experiment. From the top are the rotation speed waveform and the voltage waveform. These two waveforms show that the response after the load is applied is without delay. The purpose of this study was to make it possible to conduct synchronous generator experiments easily on a desk. The small synchronous generator experimental system was connected to a load, and the operation test confirmed the fluctuation when the load resistance was added. Thank you for listening.